In the 1950s, almost no company owned their own computer. They'd send their programs and data on paper tape or punch card to what were called computer companies, and the computer companies would run the applications for them. In that single respect, the problems of having other organisations running our applications and manipulating our data is not at all a new problem. It's a problem we've been solving for over 60 years, and cloud computing platforms haven't introduced anything new into this area. People also say how cloud computing platforms are just no different to, say, like bureau processing or outsourcing or hosting, but that's wrong. With cloud computing platform, you can literally provision a server to run your code for 1 hour and end up with a bill for 5 cents at the end of the month. Or you could decide to provision 8,000 servers and have all of them run a complicated distributed risk management calculation. 15 minutes later, they'd be built, provisioned and running your code. Bureau processing, outsourcing, hosting, they just don't offer that level of flexibility and agility. They're not in the game. As an architect, you start off thinking you need like a web front end, a tier with the business logic and a database at the back end. But it's not long before you realize you need a stateless multi-server load balanced architecture. It distributes the load across a number of servers, like in the web tier and in the business tier. And then you start to add backup, monitoring, reporting, policy, load balancers, firewalls, VLANs, port filtering. It turns into a much more complicated beast. And then you realize you need identical environments for dev, test, UAT, staging, production. What starts out as a 3-server solution ends up with over 40 servers, loads of specialized network hardware, firewalls, load balancers, and a really complicated setup. We've got to remember that any organization can become agile if they spend enough money. A cloud computing platform facilitates agility at a low cost. We need to aim for the bottom right-hand corner of the cost-benefit analysis graph, where the cost is low and the benefit is high. And that's because a cloud computing platform allows you to buy compute time by the hour and can be provisioned in just a few minutes. It means we can go from a complicated architecture diagram on a whiteboard to a fully provisioned solution in about 15 minutes. And there's just 3 steps. The first one is to write the code and design the architecture. The second one is to reduce the architecture diagram to an XML description called a service model. And that details the role of each server, how many instances are required, what ports communicate between nodes, which ones are connected inside the data center, which ones are connected to the outside to the internet, and that kind of stuff. And then send the code and the service model all wrapped up into a package file to the cloud platform provider, and then just sit back and wait 15 minutes. The cloud platform provider's system reads the XML in the service model and starts building all the servers, patching them, configuring the runtime environments like web servers, deploying your code cleanly to each server, configuring the load balancers, doing the firewalls, port filtering, VLANs, all that kind of stuff. 15 minutes later, it will all be running, whether it's one server for 1 hour or 8,000 servers for 2 weeks. It's this combination of low cost, a few cents per hour for each server, the speed of deployment, about 15 minutes, and the automation of the whole process that gives us business agility at a low cost. But just think about what sorts of business activities can benefit from this. And there's really 4 of them. The first one is on-off. The second one is growing fast. The third one is predictable bursting. And the fourth one is unpredictable bursting. With on-off, the business does its work in short time periods. It's pretty common for risk management calculations. Traditionally, say an insurer might buy several thousand servers to perform the calculations and only use them for maybe a couple of days per month. That's a lot of capital to have tied up in resources which don't get used very much. With a cloud platform, the organization just simply deploys the servers, thousands of them, 15 minutes before they're needed, and then uses them for a couple of days and then deprovisions them. Hosters, ASPs, and all the other forms of outsourcing, they just can't respond in such an agile way, but cloud computing platforms can. The physicist Niels Bohr once said, "Making predictions is very difficult, especially about the future." And this is really true of the growth rate of startups. We don't know if they're going to grow sort of almost vertically, or whether they're going to grow very slowly or moderately. Most startups will gear their computing resources for the peak demand that they predict. Of course, if that demand doesn't come, or it doesn't come at the time it's expected, then the startup, which, by the way, could be a new division within an existing big, successful business, was wasted money on loads of resources that weren't needed. With a cloud platform, all they do is have their application monitor itself so it can automatically scale itself up and down to meet demand. And that way, the investment's always at the minimum level, but the responsiveness its customers receive is always at a peak. And again, this level of agility at an affordable price is something a cloud platform offers. Let's say a high street fashion retailer has a quarterly marketing campaign. They know a long way in advance when the campaign's going to go live. They know they can expect extra traffic to their website as a result of the marketing they do. If they use a cloud computing platform, they can provision the additional resources just minutes ahead of the campaign launch and do business safe in the knowledge that their website won't buckle under the strain. They achieve agility at a low cost because they've got the confidence to delay the provisioning of the resources until minutes before the campaign launch. And as interest in the campaign diminishes, they simply deprovision the resources in line with the demand. Traditionally, organizations had to procure all the hardware, the software, the services a long way in advance because they couldn't take the risk of leaving it till the very last minute. As predictable peaks come, the website gets busier and the resources are scaled up. As the business tails off, the website's less busy and the resources are scaled back. With a cloud computing platform, there's a direct relationship between the ongoing cost of the resources and the income they generate for the business. Let's say there's a startup selling its products through a website. If, say, a celebrity is interviewed on primetime TV and gives the product and the site an endorsement, well, within a few minutes the site could go from having somewhere between, say, none or 5, 10 visitors to tens of thousands of visitors. If the site was unable to cope with the unpredictable demand, the loss in reputation might make things even worse for the site. But with a cloud computing platform, the application can monitor itself and scale up when demand increases.